Lesson 4.2 is very similar to 4.1 and ties in a lot. 4.2 focuses on a new form called point slope. If you remember from slope-intercept, it needed the slope and the y-intercept. So this one's a little bit more generic because the y-intercept is a specific point. This one just needs any old point. So this one looks like y minus y1 equals m x minus x1. Now, where does the point come in? Well, that little one subscript means basically a point we choose. M is still the slope, but x1 and y1 are parts of a point. You don't fill in the y and the x, you just fill in the y1, the m, and the x1. So then we have a full equation. Now, what are actual numbers? M, x1, and y1 are actual numbers. So this can very easily be turned into slope-intercept form, which we're going to do a bunch during this lesson. We'd start by distributing. The left side hasn't changed yet. That would be mx minus mx1. Then we would add y1, be gone on that side. All right, so I'm going to rewrite this just a little bit for us. Remember what I said, m, x1, and y1 are numbers. So this looks like y equals mx plus when I multiply these two and add y1, that should get me my y-intercept. It's always going to be those same two steps, distributing and then adding or subtracting what's next to y. All right, so forget about all this for now. That's something we'll practice later, and it'll be easier when we have actual numbers. But this works the same as slope-intercept. It's just more generic because it works for any old point. Here's a very typical problem for this type of equation. Write a point-slope equation with a slope of 1/4 that goes through some point. For us, it's -8, 3. Tells us this is our slope, so that should immediately say m to you. Slope's always going to mean m for linear equations. And here's a point. It's got an x value and a y value that we're going to call x sub 1 and y sub 1. Now, we've got this equation we're working with. So let's start filling it in. What does our actual work look like? y1 is 3, so y minus 3 equals m is 1/4. Replace that. X minus x1, well, subtracting -8 is the same as adding 8, so I'm going to change that to addition. All right? That's point slope form. That is our solution. Now, for argument's sake, because I know mx plus b is a little easier to look at, let's do the math to get it there. Distributing will always be the first step in this process. 1/4 times x is just 1/4 x. 1/4 times 8. 8 times 1 is 8. Divided by 4 is 2. Remember my little strategy there. And then add or subtract away from y. For us, that means adding 3. That would be the slope-intercept answer. Y equals 1/4 x plus 5. Okay, we can get from our actual solution to here if we want to, with those same two steps always. Here we've got a line. We're supposed to write the equation for it. Well, we don't have the y-intercept, and we're looking for point slope form. So let's keep this written down so we remember what we're looking for. All right, we do need to find our slope. Since this is on a graph, it's easy to count. It's going down 4, 1, 2, 3, 4, and right 2. All right, y over x, it should be the fraction negative 4 over 2. That simplifies to just negative 2. All right, we've got our slope, we've got our m value. Now we need an x1 and a y1. We've actually got choices here. You can choose whichever you want. I'm going to choose 1, 2. Really doesn't matter. This one just has smaller numbers and it's got positive numbers, so it looks like it'll be easier to work with. All right, y minus y1, that's y minus 2, equals m. M is negative 2. X minus x1, that's x minus 1 for me. All right, you get to choose whichever point you want. I chose 1, 2 because it looked easier. Okay, we just had to find our slope, and then the points, we should always be given at least 1 point. Otherwise, we're going to have a hard time even doing these problems. So always expect your point to be given to you. We just need to find the slope sometimes. Back to function notation, you can expect to always see this a little bit. So reminder, number in parentheses is your x, your input. Other number is your output, or y, your solution. So this is the point 4, negative 2. This is the point 8, 4. All right, we've got 2 points. We just need a slope. So let's subtract. Use our slope equation. 4 minus negative 2 is 6. 8 minus 4 is 4. I can simplify that to 3/2. That's my slope. And then I'm going to use the smaller numbers for my x1 and my y1. All right, so y minus y1, well, I'd be subtracting a negative, minus negative 2, so I'm going to turn that to plus, equals m. My slope is 3/2, that's my m. X minus x1, well, that's 4 for me, x minus 4. That's my answer. Point slope form doesn't take a whole heck of a lot of work, but the next couple examples we'll do requires us to get all the way to slope intercept. Here's 2 problems for us, just some more practice. For both of these, we're going to need to find our slope. Let's do our subtracting right away for both problems. 10 minus 4 is 6, 3 minus 1 is 2, 6 over 2 is 3. There's my slope. Negative 4 minus negative 1 is negative 3. 8 minus negative 4 is 12. Simplify that to negative 1/4. Okay. Over here, I'll use the first point for both of them. Y minus 4 equals my slope 3, x minus 1. Over here, y plus 1, remember subtracting a negative is going to be plus, it would be y minus negative 1. I've got negative 1/4, x plus 4. All right. First thing in both equations now, distribute. Y minus 4 equals 3x minus 3. Distribute. Y plus 1 equals negative 1/4 x. I got to multiply by a fraction. 4 times negative 1 is negative 4. Negative 4 over 4 is negative 1. So minus 1. It's a nice little trick. I always try to remind you guys that. Then we add or subtract this number. So it comes out to y equals 3x plus 1. Nice clean answer. This one subtracts 1. Y equals negative 1/4 x minus 2. Who cares that we had a fraction for a slope? It still came out nice. All right. So that's kind of hitting point slope form from just about every angle.